Okay, so welcome back, everybody. We're now going to enter the final session of this year's ISNTD Bites, the first time that we've done an actual virtual conference. We've had a wonderful day so far. A very, very brief overview for those of you who are joining fresh. The first session was really looking at the implementation of the Global Vector Control Response Strategy as outlined by the WHO to 2030, obviously adopted by all member states in 2017 following the World Health Assembly Resolution 70.16, where they're going to align national vector control strategies to that particular plan. We went into then the second session going right into the genomics and proteomics in terms of genomic signatures, arbovirus vector interactions, proteomics informed by transcriptomics, a new kind of approach there, fascinating session in its own right. Highly collaborative, which is what we're trying to achieve with this meeting. The third panel was the ASEAN Country Ministry of Health panel with MOH, Ministry of Health Indonesia, Malaysia, and Philippines. We were delighted that they all officially backed our World Dengue Day campaign that we've been spearheading for the last year and a half. We're asking the WHO to ratify an actual World Dengue Day. We've got the backing of those governments, plus Sri Lanka, plus Pakistan, plus Saudi Arabia, and a whole host of leading lights and the scientific community, all of which is, you can see who they are on our Dengue Advisory Group tab in the news section of the site. And in the petition as well, we should urge you to sign. We've got over 25,000 signatures for that so far. We went into the built environment and the intersections between rapid urbanization, global health, and vector control. Some fascinating solutions, and looked at how that could influence the 138,000 deaths a year attributed to snake bite deaths. 5.1 billion people out of the 7 billion global population are at risk in accordance to the WHO's own figures from snake bite. So even a small percentage incremental impact at that level is going to have a huge effect in terms of the numbers of lives saved. We went there into insecticide resistance. Very fascinating paper by Rafi Rahman, a joint venture between Fiocruz and looking at the insecticide resistance in Pakistan, in Lahore, of Aedes aegypti. Fascinating work by Malaria Consortium and Beth Polton, bringing up a very appropriate technology, smartphone-based detection of larval insecticide resistance. Fascinating on a high throughput level, amazing, frankly. So that was that. This particular session is going to be looking at neglected epidemics, global cooperation, and really kind of the future of vector control from that perspective. It really is about convergence. It really is about bringing different science bases together. And that's certainly one of the elements of the Global Vector Control Response Strategy, one of its 4 elements. Better collaborative work is one of the cornerstones of that. Whether that's interdepartmental or indeed cross-sector, and that marries and ties to the NTD roadmap, the updates to that came out in January earlier this year to 2030, where one of the key focuses is really increasing more cross-cutting, as they put it, or multi-sectorial, moving from rhetoric to actual collaborative work. So that's something I'm going to touch on this. So what I wanted to kind of show in this is really things that are going on in these areas that kind of fit into that, and just some food for thought. So I'd like to start with the first speaker, Professor Alfonso Javier Rodrigo Morales from the University, the Technology University of Pereira in Colombia. He's also the president of the Committee on Travel Medicine of the Pan American Infectious Disease Association. This is a fascinating talk, I'm sure, looking at overlapping epidemics. COVID-19 has obviously SARS-CoV is taking all the headlines, However, we can't forget the massive burden of dengue. Half of the world's population is at risk, and the countries that do get it, it's a major issue. When you look at the impact to healthcare systems of COVID-19, I'm sure we're going to see some interesting bits and pieces coming out of these presentations. So I think that's enough from me. I think I'd like to give a round of applause to Alfonso. So a digital round of applause, all the audience. I'm sure you can hear them somewhere on some bandwidth. But so it's goodbye from me and hello to Alfonso. So over to you, Alfonso.
Thank you very much. And I would like to thank the organizers for the invitation. And as you mentioned, I will discuss in the next few minutes about what is happening right now in some countries and probably in the whole region of Latin America with this overlapping situation between the dengue and COVID-19. I will address these topics about the epidemiology of dengue and other viral diseases in Latin America before the COVID-19. Then I will speak some about the COVID-19 arrival in the region, about the scenarios of overlapping or syndemic between dengue and COVID-19, and we will discuss some final remarks. First of all, when we will talk about dengue and other viral diseases in Latin America, you know that this is very similar to other regions in the world, as we discussed here in this paper we published a couple of years ago, Lancet Infectious Disease, with other colleagues, and certainly we have been suffering from different viral diseases such as dengue, as I will discuss in detail, but it's important also to mention that in our regions in Latin America and in Southeast Asia and other places, other viral diseases, other flavivirus such as Zika, yellow fever, and in the case of alpha, especially the case of chikungunya, have been very important as well. As I mentioned in flavi, the case for yellow fever, which is very important in Latin America, in the area that is shared with the Amazon region, that includes a lot of countries, especially in South America. And before 2013, we were focused especially on dengue, especially in urban areas. But after that, we began with chikungunya that affects significantly, especially countries such as Venezuela, Colombia, others later, such as Brazil. And in fact, my country, Colombia, was one of the most affected by this situation. And a couple years later, we have the arrival and the spread of Zika from Brazil to all the countries in the tropical area of Latin America, and with important cases in other countries in the region and in the continent. I always try to highlight that these new or viral diseases in the region, after this epidemic for the 2 or 3 years after 2014, became endemic. And you can see the data from the last year in my country for chikungunya and for Zika. These still came endemic. But after those epidemics in 2015 for chikungunya and later for Zika, were proceed for an upcoming again epidemic of dengue in the year 2019. And this is very important, not only in Colombia, but in other countries in the region, in Mesoamerica and Central America. The case of dengue has been very important, with an epidemic last year where the 30% of the case, 1/3 of the cases were severe cases of dengue. And this is important because it's not just the whole number of cases, such as in the case of Brazil, but also other epidemiological indicators. And we can see here in the increase in the number of cases has been very important, not only last year, but the current year, for countries, for example, also such as a big epidemic like is the case of Paraguay, or as I mentioned right now in the case of Honduras, has been very important after the epidemics also of chikungunya and Zika, especially in urban areas, in cities, in capital cities of these tropical countries. And not only in this area, but we have poor areas with conditions proper for the transmission. This is the case of Colombia. And as I mentioned, not only for dengue, but for many other emerging and re-emerging viral diseases, such as Mayaro, Oropuche, among many others. If this is not enough for the region and for the health systems, we have now the arrival of COVID-19. Everybody now, of course, is affected in the world. And soon after the beginning of the epidemic in China, we were awaiting the arrival from this country to other countries, not only in Asia, but also here in Latin America, in Asia, as has been common. And in Latin America, from the Society of Travel Medicine, we were advising about this situation of the possible arrival of this epidemic that initially in the continent has its core in the United States, and then especially moved to the case of Brazil, which has been very important, but other countries in the region has been also a matter of concern, especially from the arrival of COVID-19 from European countries, such as is the case of Italy. And we were discussing these implications in this early editorial of Travel Medicine Infectious Disease, especially advising about this situation, the problems, the cultural problems of the region, but especially the case of the overlapping with other epidemics, such as the case of dengue. And very quickly, we have in the region imported cases from Italy and Spain mainly, and with inequalities in the region, because other countries were presenting already a large epidemics, for example, of dengue, measles, and other vector-borne diseases, not only arboviral, but the case of malaria in Venezuela is particularly important. Right now in the region, we have a very significant epidemics, especially in Brazil, but in other countries such as Mexico, Peru, and Chile, and now Colombia. And certainly we are struggling in the region with this situation. In North America, Mexico, which is part of Latin America, in Central America is very important, the case of Panama, but certainly everybody in the region speaks about the situation in Brazil. Brazil is now progressing with millions of cases. And right now we have also problems in other countries, as I mentioned, in Chile, in Honduras, and this may present this situation of the overlapping of syndemic. For example, Ecuador has been very affected by COVID, and in the past by other arboviral diseases such as chikungunya and dengue, as we show in different papers. In especially areas such as Guayas is highly endemic for these arboviral diseases, and now is highly affected by COVID-19. And we were discussing the implications of this for dengue co-epidemics or overlapping. And especially in Colombia, we have been analyzing this situation in this paper, Journal of Medical Virology, because in the past, we have been affected with thousands and hundreds of thousand cases of dengue. And right now we have this situation of the emergence of COVID-19. As you can see here, in the last year, we have under epidemic situation, and in the past, as I show, we have also other viral situations, which have been very important. Here you can see both epidemics, and right now, there is an increase significantly in the number of cases of COVID-19, but in certain areas, especially in the coast, we have simultaneously both epidemics and also in other regions, such as is the case of Valle del Cauca, where it's Cali, the third most important city in Colombia, affected significantly by dengue and at the same time COVID-19. Other countries also endemic for this, which is the case, for example, of Bolivia, of Peru, Brazil, have been now reporting the same situation of the simultaneous occurrence of COVID-19 and dengue. And this is also important, for example, in the north of Peru, in areas such as Iquitos, Chiclayo, among many other, and also right now imported cases not only of SARS-CoV-2, but also of co-infections between dengue and SARS-CoV-2 are now reported in the literature as this one, which was not in Latin America, but in the in the Ocean Indian, in the island of Mayotte to France. And this is an important thing that we will see for the next following months in endemic areas, where we are now looking this deadly duo, as has been reported in tropical duck. But certainly other countries and in other regions that are also endemic in the past for dengue are concerned about the situation. And this has been the case of Bangladesh, and other communications from Malaysia and from Pakistan are discussing right now the situation of co-infection and co-epidemics of COVID-19 and dengue. As final remarks, I would like to highlight that both conditions may progress to severe forms, as is well known in the case of severe dengue, which has been very important in our epidemics in Latin America, and both then may require internal intensive care units, critical care, and right now in the COVID-19 epidemics in Latin America, in many of our countries, our ICUs are already collapsed due to COVID-19, and this is a problem with dengue. For example, last year, our ICUs in the highly endemic areas for dengue were also collapsed, but due to dengue, then this is a matter of concern. But there is also concern that has been raised about false positive serological tests and cross-reactivity between dengue and SARS-CoV-2, reported in a paper from Singapore in Lancet ID. And we are not clear yet about the importance of co-infections, if the prognostic and the evolution of these patients is really worse than SARS-CoV-2 alone. And also, as we have been concerned for many other impacts in the healthcare system, there is also a concern about the COVID-19 impact on vector control, because there is a lack of different activities, including different disease control disease programs, including vector control. And finally, this endemic of these epidemics certainly pose a challenge for the healthcare system, especially in most deprived countries in the region, such as is right now the case of Venezuela, Haiti, and probably others, especially in the Caribbean sub-region of Latin America and the Caribbean. I would like to finish to invite you to visit our website, lancovid.org, which is the website of our Latin American network of coronavirus disease 2019. We have a lot of info there, and most of our published research there. And our final slide to say that, as was said by the poet Luciano Garcia Gomez, in Pereira there are no foreigners. We are all Pereirans. And in the last seconds, I would like to dedicate this presentation to my lovely fiancée, Catherine Bonilla. Thank you very much for your attention.
Thank you very much, Alfonso. I think that was the most loveliest end to a presentation I've ever seen. So thank you very much for that. Fascinating, the reality of co-infection reality. You mentioned the Lancet ID paper. Gabriel Yan, who wrote that letter from the Singapore National Hospital, he was the first person that we got in contact with 14 weeks ago when we did our ISNTD Connect. And that video is on our website. We can even post it on here. And we got in contact and we had an hour and a half session with him in a webinar that we put out everywhere about what happens when a patient presents themselves and this whole in the clinical setting with COVID with dengue is a very beautiful slide in that presentation, which shows the overlapping clinical manifestations, overlapping the two, the dengue and COVID. And this whole thing about the false hit positives in serological tests, he raised that as well. And I definitely say, that's something to kind of consider and move forward. The effect on healthcare systems. I was in Lahore earlier this year for the I was speaking at the ICD 2020. The government had the first ever government-sponsored dengue conference, and I was there as an international speaker on community engagement. When I conducted a series of interviews there with some of the government of Punjab, some of the ministers there, some of the people, Dr. Somya Iqtidar as well as an example, they're telling us that when the dengue outbreak happened in 2011, 2012, there were about 5-6 hospitals in Lahore with resource limited settings. 5,000 people a day were presenting themselves when the initial outbreak happened. So one can imagine, I don't think we fully grasp here, in Europe at least, the actual stresses are on that healthcare system in these settings. And it's something that definitely needs to be brought to far better awareness, and it definitely needs to drive the policymakers to increase hospitals, educate the doctors in a different way. There's so many different gaps that need to be filled. So I really want to thank you very, very much for that beautiful overview from a Colombian perspective. I thought it was excellent. Excuse me. It's not COVID. I'm just coughing. I've been awake for a day and a half prepping this, so don't worry. I would like to thank you very, very much for that. It was a wonderful presentation, and we can you can post your website onto the news section of this virtual world, and this will remain live forever as a hub for everybody. So all of this session will be replayed. People can contact. It's there for everybody to use from a cross-sector perspective, not just the epidemiologists or just the clinicians or the diagnostics or the vector control. We want everybody together because that's how this is going to work. So that's I think that's food for thought. So a digital round of applause for you, and Alfonso, we'll join you back for the Q&A at the end.
Yeah.
And I'm going to move to the next speaker. So thank you very much. I love the quote at the end as well. Beautiful. Thank you.
Thank you very much.
Thanks a lot, man. Thanks. Okay, so fascinating. And the next speaker that we have to join us is Professor Thomas Weitzel from the Instituto de Ciencias e Innovación en Medicina, the Universidad del Desarrollo in Chile. My Portuguese is terrible and my Spanish is terrible, so apologies in advance. We wanted to bring Professor Weitzel here because scrub, typhus, mites, bites, and all this kind of new emergent thing to it, and actually try to unpack the disease burden here somewhat, or unpack, what this is and what's needed from a global cooperation perspective. So I'd like to just get to I'll just kind of, hi there, Thomas. Yeah.
Hello.
Looking very clear. It's very good. And so I'm sure the weather's very good in Chile as well. We've got actual sunshine here in London for the first time, so it's fantastic. It's it's brilliant. Thank you, and I'm gonna back out of this and leave the floor to you. So a round of applause, digital applause, all the audience for Thomas, and we'll speak in a bit. Thank you.
Yeah, thank you very much. Yes, I'm going to present here from Chile. I'm actually a German doctor, but I'm living in Chile since 10 years. I can also confirm that the weather is very nice here. I have a view on the Andes that are with a lot of snow at the moment. Thank you very much for the invitation. I'm going to present the newest data, or the data of the last 3-4 years, an update on the work of our group here that dedicates itself to vector-borne diseases and specifically Rickettsias infections. I hope everybody can hear me. I'm gonna try now to switch on and share my screen. So now maybe one short feedback. Can everybody see the screen? And maybe I start with the first slide. Again, thanks for this opportunity to present our data. We are a group of several doctors and veterinarians, mainly also working clinically and part-time scientists. And as you might know, usually on conferences and meetings on vector-borne diseases, Chile is underrepresented because Chile probably is one of the few countries in the world that until recently really didn't have any problems with vector-borne diseases. In sharp difference, for example, to other Latin American countries like Colombia, where there's a multitude of parasitic diseases from Leishmania, malaria to arboviruses, etc. Chile, until recently didn't have any vector-borne diseases except the occasional dengue outbreaks in Easter Islands. You know that Chile is, of course, endemic for Chagas disease, but the domestic transmission of Chagas is controlled for more than 20 years. So I hope keep you interested, because I will report on some very important news regarding vector-borne diseases in Chile. And I think not only interesting for Chilean doctors or for Rickettsiologists or experts in tropical medicine, but also for other countries in South America. And at the end of the presentation, I want to discuss a bit what implication this might have on a global scale or on our ideas and approach to vector-borne diseases. So as I said, in Chile, and in this talk, I will not talk about arboviruses and not about parasitic diseases like malaria or leishmaniasis, which are also important in South America, but about rickettsial infections. Rickettsial infections, as you can see in the bottom, are transmitted mainly by ticks, but also by fleas, lice, and also very few of them by mites. And if you are not familiar with rickettsial infections, there's a very short summary on the right. They are vector-borne, they're zoonotic, and they are emerging, which means that, and this is the map from a paper that's already quite old, all these spots are emerging rickettsial infections. And why are they emerging? Basically, if you look at the clinical summary, it's mainly because they're very difficult to diagnose. That means with our increasing diagnostic tools, molecular tools, we found more and more rickettsial infections all over the world. Are they clinically relevant? They are very relevant because among the rickettsial infections are one of the most deadly infections that we know. So it's actually very important to know which Rickettsias you have in your region. The good news is that they are very easy to treat. They usually respond very well to doxycycline. And this is a typical example of a patient. That's a patient that I saw in Berlin, a tourist from Italy, that came back with this rash, highly febrile. He was on intensive care, renal failure. And as you see, he had this typical eschar, this necrotic lesion at the site of the vector bite. And he had it was a typical case of Mediterranean spotted fever. So, like I said, our group started to dedicate itself to rickettsial infections in Chile about 10 years ago, when there was nothing known about Rickettsias in Chile. And as you see on the left side, during the years, we were successfully isolating or identifying two Rickettsias, Felis and Andeanae, a new species in ticks and fleas. Both species are probably not very relevant for human medicine, because they're not probably not causing a lot of disease. We also found rickettsial pathogens, but affecting more veterinary medicine, Leishmaniasis and Anaplatis, which are very important pathogens for dogs. But we were still hoping and looking for human cases, and the picture of human cases changed in 2006, actually, with a randomly diagnosed case from an island in this southern Chile, Chiloé Island. And it was actually affecting a colleague or biologist that came back from field work with a clinical picture. And you see the similarity to the slide before, with a fever, with this rash, this typical spotted rash, and with also this inoculation eschar, which was treated with doxycycline. But then the question was, what did he suffer from? And this was analyzed with rickettsiologists in all over the world, mainly in the United States, which at the end diagnosed this as an Orientia-like bacteria. And as you see, the publication came out 5 years later, so it was a long process. And as you can also see, that the authors were very careful with their statement. And why is that? It's because Orientia and scrub typhus is a well-known disease and known since many centuries, but it has some paradigms and facts. And those mainly say that this is a geographically restricted disease, only found in this area in Asia Pacific, which is called the Tsugamushi Triangle. In this area, it causes a lot of disease. We think that it's far more than 1 million cases per year. The exposed population is over 1 billion, and also causes quite some mortality per year. And it's caused by a unique species, Orientia tsugamushi. That's the paradigm or the fact. And it's transmitted by certain mites. And as you can see in the picture on the left, these mites mainly live in the soil, and only the larvae come out and parasite on different vertebrates, mainly rodents, but also other animals, and occasionally also humans. And these mites of the genus Leptotrombidium are not only the vector, they are also the reservoir of the disease. So the disease occurs in regions where there are infected mite populations. And another thing that we think is that it's a very rare disease in travelers. So it belongs definitely to the group of neglected zoonotic diseases or vector-borne diseases, mainly affecting rural populations in these areas in Asia. And as you will see, we will break with some of these paradigms in the next slides. A bit more, or some pictures on the vector. As you can see here, or maybe, I don't know if you can see it, those mite larvae, or chiggers, how they are called, are usually reddish to orange. And if you have good eyes, you might see them. They attach to the skin for a couple of days. They don't suck blood. They live off liquefied skin juice. And after some days, they detach, and then they continue with their life cycle in the soil. There's a variety of different species that attack humans and that transmit scrub typhus. Well, for us, in our search of clinical cases in humans, this case report was the reason that we included in our studies this island, because before we had looked more in the central and northern parts, because we were, like most rickettsiologists, more focused on ticks. And the southern parts of Chile, there are no ticks or less ticks. So we first didn't plan to look in this area, but then included Chiloé Island. And after starting this study in the first summer in 2014-15, we had our first case. that presented also with a very typical clinical picture. The patients are severely sick. They are highly febrile. A quarter of them have also CNS manifestations, so this is not a harmless disease. As in the first case, we also looked for confirmation of this case, and in this case, we worked together with colleagues from Oxford and colleagues of the Oxford group in Southeast Asia, and could confirm the case again as Audiencia, or probably Audiencia Tsutsugamushi, or close by molecular techniques. You can see on the right the signals from the ESCA material and also from the Buffy code and the phylogenetic tree. And also we saw some seroconversion, so it was also confirmed by serology as a case of scrub typhus. And putting together all this data, the next summer season, we had a couple of more patients all presenting with this typical clinical picture. So we basically had the chance to publish this as a new endemic disease in southern Chile or in South America, which of course raised a lot of questions, because as you can see, this is a focus of this disease very far away from the endemic regions. And this of course raised a lot of questions. If it's in southern Chile, where else might it be? What is the clinical relevance? We also didn't know anything about the vectors, the reservoirs. And of course, the question in nowadays, the origin in our world of moving people, moving animals, etc. Was this something recently introduced, or was it something an ancient disease? So our group, and this is a photo of us together with our partners from Maryland, we applied for a new project and tried to answer some of these questions, and the project is still ongoing, you see, from 17 to 21, and I want to give you an update on some of the results that we already have. First important result is that this disease is not only confined to Chiloé Island. We found by now various cases, about half of the cases on continental Chile. And as you can see on the left, this is a publication from last year, or the data from until last year. This area is a long area. We have also recently found a case much further south. So at the moment, the range is over 2,000 kilometers. So we can say that this is not an island disease. It's a disease that affects wide areas in Chile. All the people report usually activities in close contact with nature. It's not a surprise when we think about this vector-borne disease. And we also see a clear seasonality. Until recently, I would have said we see only cases, and we have up to now over 60 cases in the summer months, but also this shouldn't be a paradigm, because we 2 weeks ago had our first case in winter. Usually, if you want to know about the epidemiology, you look also at seroprevalence data, and here we did our protocol that usually for the tick-borne diseases, where dogs are a very good sentinel. So we looked at dogs that are usually highly exposed also to vectors such as ticks and mites, and we could confirm that on Chiloé Island, a relatively high percentage, over 20% of dogs were seropositive. And we used also cluster analysis to look for hotspots that we later used to look for the vectors. Here's some data that were published a couple of weeks ago about human seroprevalence, but here we can see that we probably don't use an antigen that's very well, you know, that this is the antigen. The antigens that we use are from strains from Asia. What we find is basically a seroprevalence close to zero, and all over the country. So I think this is not the answer yet, and we will repeat this with antigen-strong Chilean strains. For those of you who are interested in clinical medicine, infectious diseases, tropical medicine, a very short summary of what we have seen so far clinically. So as I mentioned, we see patients that suffer acute febrile disease. Almost all of them have this typical eschar, which is a local necrotic lesion, mostly on the lower limbs or at the trunk, headache, myalgia, and also in a high percentage, 90%, we saw that they had a rash. About half of them required hospitalization. All of the patients responded well to doxycycline, and up to now we had no fatal cases. So for the audience here, probably more interesting, the question, what is the vector? The vector was unclear, and at the beginning it was even discussed if it might be transmitted by terrestrial leeches, because the first patient had been attacked by leeches, and he associated this lesion with a leech bite. We never had any confirmation of that, and we started our field projects looking also for mites. Until then, there was no information on mites, the existence on trombiculid mites in Chile, in these regions. So we did several field studies by now, collecting rodents. That's usually the approach. And here we chose, as you can see, 6 locations in northern Chile where we trapped rodents. And as you can see on the right, you have to do that in Chile under basically Ebola conditions, because we have Andes virus, the Chilean hantavirus, which has a lethality rate of 20 to 30%, so you have to be very careful. And to our surprise, we found that in this study that was also published recently, more than half of the rodents were affected by trombiculid mites that you can see here. These orange spots are conglomerates of chigar mites. So we saw that in all of the sites, rodents were affected by mites, and also we saw, using our qPCR, that a significant percentage of mite pools, 16%, were positive for Audientia. And of the 3 different mite types or morphotypes, it was herpetocarus that was positive. And as you see on the right side, we could also see by sequencing that the isolates from the mites were identical to the Audientia isolates from the humans, which is a strong suggestion that these mites are the vectors. The final identification of the mite species is underway, and actually it's submitted this paper. I will talk about this at the very end. There's very few people in the world that can identify chigar mites to the species. And we have a young acarologist in Chile that works with us, and we're working together with a senior acarologist in Russia. And maybe that's not a surprise. Two of the 3 mite types or species that we found were species that had never been described before. So this is completely new information, a completely new vector. Also, of course, very interesting, the question, is this Audientia tsutsugamushi or a different strain or a new species? And we have already also analyzed this, and this is also going to appear next month in Emerging Infectious Diseases. And it's actually the case that the Audientia from Chile constitutes, to our opinion, a new species. So we have a new species of Audientia, which is going to be called Audientia chiluensis. As it is described in this paper only molecularly, it has the name also candidatus in front. So we have new vector species transmitting a new Audientia species, causing scrub typhus, clinically pretty similar to the Asian forms. This is the summary of these findings. Like I said, a new infection affecting large parts of Chile and probably other parts of South America, caused by this new species, clearly with a seasonal transmission, affecting people that enter the nature, and we see that it also affects tourists. Typical tourists in Chile, in southern Chile, are people that do hiking and fishing, etc. Up to now, we don't have very severe disease. We have no fatalities. We have very good response to doxycycline. But we still, of course, have many open questions because we don't know the full range. We don't know the origin, but we have some ideas of the origin. I mean, that is, it's a new species and also new vectors. Indicates basically that this is also a disease that was not recently introduced, that probably has existed for a long time or forever in this region. And as I will show also or discuss in the next slide, many parts of the vector ecology and prevention, etc., are completely unknown. And this is now basically the last slide, and a bit bringing this into perspective, or asking some questions that go beyond the relevance of a new disease in southern Chile, is for me, as an infectious diseases doctor, how could it be that such an important and dangerous and I think not infrequent disease in South America could be unrecognized since basically 5 years ago. Yeah, and to answer these questions, me and some other colleagues that work in mites and Rickettsias did an analysis of the knowledge, or to see what do we know about mites as vectors. And there on the right side, you can see as a proxy an analysis of the PubMed publications. And as you see, the blue lines represent the mosquitoes and the tick-related publications as mosquitoes and ticks as vectors. And as you can see in the lower part, the red line, are the publications per decade, per 10 years of mite-borne diseases or mite-transmitted diseases. And this clearly shows that the scientific community has, in the last 50 years, completely ignored mites as vectors. And here on the left side, also some I don't want to point some special sources out. It's just you can look at any source. You can go to any conference on vector-borne diseases. This, for example, this brief from the WHO, this series of conferences from a network on neglected vectors. The word mite doesn't exist once. It doesn't appear. The identification and the work with mites is very difficult. As I said, there is hardly any experts in the world that can identify mites to the species level, and there's no genetic tools developed at the moment. So if we look at mites from a scientific point of view, we have to realize that with compared to mosquitoes or ticks, we are in the same level as in the 60s or early 70s with other vectors. And this is basically the last slide. I know that the most important vector-borne diseases are probably transmitted by mosquitoes, and there's also more and more knowledge about ticks. But I think the community that deals with vector-borne diseases has to also recognize that there's also vectors that are neglected, and maybe there are more diseases that are not even neglected, that are unknown, because we are not looking enough at the whole range of vectors that exist. At the end, I want to thank all the people that helped us in the last years from all over the world, Rickettsiologists from the United States, from England, from South America, a big group of people that were involved in this work. Thank you very much. I don't know how this ends now.
I have to come back on. Thomas, I think we have to give you a standing round of applause for that. As that was unfolding, it was like watching the end scenes of Hercule Poirot or Sherlock Holmes, the end scenes of a Sherlock Holmes novel. Epidemiology detectives. There should be a new series. That was absolutely amazing. 2 new species of mites, everybody. There's not a small, that was incredible. When we saw the paper, we were adamant with each other, Marianne and myself. I know Marianne content, we have to get you on board. So thank you so very much for that. That is a real eye opener, especially the cumulative. Sorry, something with some kind of. Just hang on 1 second. I think I know what it is. Here it is. No, especially the cumulative echo. The cumulative part at the end with the amount of research done in mosquitoes, ticks versus mice and mites, shocking. And one wonders how much more is out there, how many other diseases are yet to be, vectors and diseases are yet to be uncovered. So, I mean, what an amazing presentation. Thank you very, very much for that. I feel very enlightened after that.
Thank you very much. I mean, I saw that there's also lots of colleagues from Africa, and I didn't discuss in the last slide. There's also the map. Actually, there's also new data now since the paradigm is broken or shifted. There's also now more people looking into rickettsial diseases and scrub typhus, and there's data from Africa actually that also suggests that this might be also that there might be also probably a new species causing scrub typhus in Africa. Yes,
it's very interesting because in March earlier in the year, we're championing a disease called Noma. It's in Nigeria in the Sahel. Nobody's heard of it. MSF have made a film about it. We gave them an award for the film earlier in the year. It's a bacterial infection of the gum, and it leads to unchecked complete collapse of the face in children. They have to have huge surgery, and there's just not even the basic research hasn't been. There's nothing out there on it, and yet it's affecting people. So. That really had a lot of resonance, your approach, and I dare say it's like a blueprint almost of how to go out and find these neglected vectors. And I would love to keep in touch with you, Thomas, in terms of this Noma work. That's in the Sahel. There's a few places in it's in Nigeria. That's with MSF, and we're looking at something. I'll email you. We'll email you something after if that's okay.
Sure.
Thank you very, very much. And thank you, a huge round of applause for that. For time, I have to move on to the next speakers. We will have quite an interesting conversation, I'm sure. Enjoy the Andes, and So we'll catch up after. I'm going to go to the next speaker. Thank you. So wow, that was rather an amazing. I've got a lot of food for thought there. What a great presentation. And that kind of leads us out into the last presentation of the day by Dr. Claire Heath from the Stanford University School of Medicine. The work was carried out in Kenya, and it's really looking at the evidence of transovarial transmission of chikungunya and dengue viruses in field-caught mosquitoes in Kenya. And we wanted to kind of frame that in terms of implications for future outbreak risks. So I'm just trying to load this up. Sorry, here we go. Claire, hello there. Dr. Heath, how are you?
Hi, good, thank you.
Great. Would it be possible to turn your sound up slightly? I'm sorry, unless I've gone deaf. I haven't slept for 24 hours, so I'm trying to prep this and do this. So maybe it's me. But
Is that any better?
uh,
Not very nice.
yeah, I think so. Layla, is that okay? Yeah. I mean, we can hear you. It's not that loud, but yeah, we need more sound. She's saying, I'm being told by the tech guru Layla that we need more sound. It's okay. If you is your computer turned up?
Yeah, I've got a sort of separate microphone.
Ah,
Oh,
no, yeah.
hello?
Yeah, no, we can hear you. We can hear you. I think it'll work. You have to speak louder. We'll go lo-fi. You have to speak louder.
And wake you up for the last presentation.
Yes, that's what we need. So thank you very much. And so I'm going to back out of this, and we'll all reconfigure for the end. Thank you very much. All right, thanks.
Okay, so forgive me if I'm shouting, but I'm just hoping that you can all hear me. Thank you very much for the opportunity to present today, for the invitation. And I'd love to present today on what's been a really long-term and truly collaborative, truly internationally collaborative piece of work that we recently published last month, finally. So can you see my slides? Sorry. Hello?
It went for a second, but now we can hear you again. We can.
Here we go. So as I say, this piece of work has been a very long-term piece of work and an international collaboration, which we've proudly published recently. So of course, I don't have to convince this audience that arboviruses, mosquito-borne viruses, are amongst some of the most important emerging pathogens in the world due to their geographic spread and their increasing impact on vulnerable human populations. Notwithstanding that, their transmission, epidemiology, and their incidence remains poorly defined in Africa relative to South America and Southeast Asia. But of course, better understanding them is imperative to better informing human risk assessments, and of course, as we talked about, the implications of vector control practices. So the mechanism of transovarial transmission or vertical transmission is the spread of a pathogen from a parent mosquito to its offspring. And this mechanism aids in the amplification of viruses in the environment by, of course, increasing the number of infected vectors in a particular region, and of course, thereby expanding the possibility of transmission into humans. It serves another purpose as well by keeping the virus quiescent during seasons where vector proliferation is maybe more difficult, for example, during dry seasons. And so the objectives of this study were to characterise, first of all, the inter-epidemic circulation of arboviruses in rapidly changing environments in Kenya. And by that, I mean urbanisation, rapid urbanisation and increased population growth, of course, which is conducive to vector proliferation. We also wanted to characterise the prevalence and spatio-temporal distribution of chikungunya, dengue, and we did look for Zika as well in these mosquitoes. And after that, to investigate the rate of transovarial transmission of these viruses to see what the contribution of that mechanism is in an endemic setting such as Kenya. So first of all, let me describe our study sites. We chose 4 sites, 2 on the coast of Kenya, on the Indian Ocean coast, and 2 which are to the west of Kenya on the shores of Lake Victoria. Chilaimbo and Kisumu in the west, Chilaimbo, which is a rural setting, Kisumu, which is urbanised, and Ukunda on the coast, which again is urbanised, and a rural setting on the coast, Masambweni. So we really had sort of a mixture of settings for the study. So in a nutshell, over the period of about 2.5 years, we collected mosquitoes monthly from these 4 sites as part of a RO1 project by Dr. LeBeau at Stanford. We collected vectors at all stages of their life, eggs, larvae, pupae, and collected adults as well from the wild in sentinel traps from human landing catches, and also a really cool mechanism of backpack aspiration, where we essentially went out and vacuumed them up out of the air. So that was pretty cool to do. At each of the settings as well, we installed rain gauges to be able to monitor rainfall data, as of course vector proliferation and spread is known to be correlated with rainfall data. So we installed those too. And then at the end of all this, painstakingly, all of these mosquitoes were sorted by their sex, the trap type that they were collected by, their date of capture, and grouped into pools, of which there are just over 700. It varied between life cycles, but there were roughly 25 individuals per pool, but the range was 1 to 36 individuals per pool. We used their legs actually to ensure that any infections that were detected were disseminated infections, rather than just the result of them recently having taken on an infected blood meal from a human. So it was the legs that we used. We lysed the tissue and extracted their RNA, and then tested them by a multiplex RT-qPCR reaction, looking for the 3 viruses I mentioned. We then performed all the statistical analysis to determine what the positivity rates were between the different trap types and life cycles, and looked at their infection levels between the different life cycles as well. And so these results really just serve to show the sort of workflow, and HLC stands for human landing catch. Protopack was the backpack aspiration, the sort of vacuum mechanism we used to collect them. And the BGS were the sentinel traps, where they're carbon dioxide traps at the...
Sorry, I'm very sorry to interrupt you, Claire. I've just been asked by some feedback. Could you possibly run the slideshow so it fills the screen and it would be easier to see? I'm so sorry to interrupt you.
Absolutely.
Thank you. Perfect. Thank you.
So these are a little confused, but just regard these slides as a workflow. So these just show the number of mosquitoes. These are the adults that were collected by human landing catch mechanisms, the backpack aspiration, so the vacuuming up out of the sky kind of mechanism, and the sentinel trap, which is a carbon dioxide based trap that the mosquitoes fly into. And the numbers underneath just represent the number of pools, the absolute number of pools that they represented, and the proportion of the total number of pools that we collected. And then each of them were tested for chikungunya and dengue. And then you can see that the proportion of, in adult mosquitoes, the proportion of mosquitoes that we collected were largely female, with the exception of there was 1 male pool for each of the protopack and the sentinel traps. But if you compare, the takeaway message from that is that most of the adults were females, and with the human landing catch, that was exclusively so. If you compare that to the immature mosquitoes, as you might expect, the sexes were more evenly distributed between male and female. So that just sort of gives you an idea of the sorts of numbers that we were collecting. So in a very simple summary of our results, as I said, we had 714 pools of roughly 25 individuals each, and about 6% of these were positive for chikungunya, and 0.4% were positive for dengue. More arbovirus mosquitoes were found in coastal Kenya than in the west, and chikungunya was found in both coastal and western Kenya in urban and rural settings, but dengue was only found on the coast. We didn't observe Zika virus at all in Kenya in our samples. And such regional variation in viral disease prevalence is, of course, at the moment of particular pertinence with the ongoing viral pandemic at the moment. So this one, I think, just to summarise quickly, although a total proportion of the specimens were from pupil traps, a large proportion of those, relatively, were positive for virus, whereas conversely, the ovary traps accounted for a large number of total specimens because, as you can imagine, we were able to collect up lots and lots and lots of eggs relative to catching an individual adult, but they accounted only for a small proportion of positives. However, when you group them together as either adult or immature, the contribution to the total positives was about proportionate to its size. There was roughly a 70-30% split, adult to immature. But when we express this as a maximum likelihood infection rate, as you might expect, the infection rate was higher in adults than in the immatures. In adults, about 81% were blood-seeking females. However, in the immature mosquitoes, the positivity was split more evenly between the sexes, with only one positive pool, as I've shown before, from the sentinel trap and the protopack. So this is a really complicated looking slide, but it's basically breaking that slide down into a bit more detail. The maximum likelihood of chikungunya infection rate was about 0.7% on the coast overall, compared to only about 0.3% on the coast, so more than double actually. And the infection rates on the coast for dengue and chikungunya exceeded the upper confidence intervals than that on the west. So again, that's really showing the differences in regional variation in the country. And although the rural sites yielded more positive pools than their urban counterparts, the calculated infection rates actually didn't differ significantly between urban and rural. So the regional variation was really sort of disparate. If we look at the sort of the bar charts, these show that in the west, chikungunya, the west is the bottom chart here. Chikungunya and dengue were not detected in the latter half of 2014 or 2015. So there was nothing for a long time, which, as you can imagine, was pretty discouraging at the time. And then sort of resumed again in early 2016, whereas on the coast, both viruses were detected throughout the study to varying degrees. And the peaks roughly corresponded to the times of peak rainfall, as you would expect. So, in summary, there were more arboviruses in the coast than the west. In chikungunya was found in urban and rural settings. Dengue was only found on the coast, and chikungunya was observed across all the year and seasons, whereas dengue was observed only sporadically and in single pools. So I've already done that one, haven't I? I beg your pardon. Oh, I'm going backwards. Sorry. So just to really summarise simply, although our infection rates were higher in adults, the positivity at lower levels was more temporarily persistent in immature mosquitoes, which provides evidence that transovarial transmission does contribute to viral maintenance during times when vector proliferation might be adverse, as I say, during the dry season. And I just like this chart because I think it just shows that, yeah, you get the peaks in the adults where it's high positivity rates, but there is this sort of persistent low-lying positivity rate in immature mosquitoes, which is evidence that this is a mechanism by which viruses persist in interim epidemic periods. So in conclusion then, dengue and chikungunya are in circulation in Kenyan vectors in both rural and urban settings. And in particular, chikungunya was found to be endemic and circulating during all seasons, but their maximum infectivity rates coincided with periods of increased rainfall. the virus presence in immature mosquitoes of both sexes as compared to largely, well, almost exclusively females in the adults demonstrates that transvarial transmission of chikungunya and dengue during inter-epidemic times in Africa and detection of these viruses in immature mosquitoes across all years and seasons show that this mechanism contributes to viral maintenance in environments that are adverse for vector proliferation. And we said that to put this in the context of sort of further work and what now, what from here, the so what. So this study provides some of the first evidence of transovarial transmission of chikungunya and dengue viruses in Africa during inter-epidemic periods, which of course has very important implications for persistence and epidemic patterns. The isolation, of course, we detected the virus by PCR, and so we endeavour to absolutely actually isolate the virus itself from the samples, which will substantiate the evidence of transovarial transmission. We realise that transmission competence between different Aedes species may also play a role in transovarial transmission, and so we are now endeavouring to characterise differences in rates between local Aedes populations, which will help inform risk management policies and human risk assessments. And I really want to finish off by saying it really did take several villages, actually. And there are so many people at Stanford, at Kemri in Kenya, NASA, Case Western, Emory, and of course the Ministry of Health in Kenya. And some of those people are pictured there, but it really was a truly collaborative effort. So I'd just like to acknowledge all of the people that have been involved in this work. Thank you.
Thank you very, very much, Claire. A round of applause for that. That was absolutely fascinating. And we saw that paper, and the persistence of the virus outside of the dengue season or outside of chikungunya, the seasonal outbreaks. What a seminal bit of work, really, because, you know, you've put it there in the future direction of the work. Listen, some of the questions we're I think we're going to try and get in there. We've got about 10 minutes before I get cut off electronically to bring the panelists back. But I mean, that has some very big implications in terms of the management of that throughout the year. Everyone we talk to talks of the seasonal dengue outbreak. You get over 41 degrees and suddenly everything's kicking off.
Yeah.
But this would completely rearrange the entire way of looking at this. That's absolutely fascinating. Then the nuances between the two species themselves and how they have this persistence. And I think that's absolutely fascinating. And thank you very much for that. I just want to bring the Alfonso and Thomas back, if possible. Thank you. Brilliant. So, I mean, the reason we put this particular panel at the end, it really is about collaboration, and it really is about convergence, right, in terms of future movement within this. And we've always said this from day one. This is our 8th year of being alive as the International Society of NTDs. And we've always said that vector control is one of the key, probably the pioneer. Yeah, it's pretty obvious, but what I'm trying to get to is that in order to drive further collaboration, meaningful collaboration, you have to identify the gaps, right? Where are the gaps in knowledge, what's missing, and then so once that's defined, then the collaborations can take place. It might be veterinarians, in your case, Thomas, it might be a whole different set of skill sets when you're looking at COVID plus the co-infection of COVID plus the dengue. In your case, we've just discussed that as well, Claire. So what I wanted to ask really, in your opinion, because we've only got about 10 minutes, we've got a load of questions from the audience as well, which we're going to put onto the lobby, and we're going to tease out a kind of white paper from this. So we will be putting them to you, if that's okay with you as panelists, but later, and then over the next course of the week, when you've got time to answer, we'll construct something out of that. But just to kind of to go through, where do you think the gaps are from a vector control perspective? From what are those gaps? I'll ask Alfonso first, if you don't mind, because anti-clockwise is always good for me.
Yeah, well, I think that in Colombia, as well in many other countries in Latin America, regarding vector control, especially for dengue and other arboviral diseases, as well in malaria, is that probably we are not well yet adhere. There is not enough adherence to multisectorial approaches for the vector control. And this has been advocated a lot by World Health Organization, and certainly it has been very difficult in our countries to reach that goal, because certainly vector-borne diseases as well, in general tropical diseases, are not just health issues, but in general social issues. And we need not only the involvement of health authorities in our countries, but from other sectors. And that is still a hard thing to make change in certain countries. Certainly in the specific case of Colombia, from 10 years ago, the National Plan of Public Health advocate for that. And in the paper is very well, have been well designed and planned, but in the real practice is not well performed, because other sectors different to the health authorities are not really involved in different key approaches that are needed for an effective vector control.
That's very interesting. I'm going to come back to that in a second. I think we do actually have an answer as a community, but I'm just going to I'll come to that in a second, Alfonso. Thank you for your honesty there. Thomas, may I ask you, it's going anti-clockwise. So.
Well, from my point of view, I think that the basics of any vector control are the knowledge of the ecology and the influence on vector, pathogen, and human or animal, climate, environment, etc.
Yeah.
So I think we have to advance in these fields. And as I showed in some of our vectors, we are basically, we know almost nothing.
Yeah.
And some of the vectors, it's also even not acknowledged that we know nothing. They are simply ignored as if they don't exist. And I think from my point of view, for rickettsial diseases, we have to start to accumulate knowledge to recognize these vectors. And then as a second step, of course, to look for control measures.
Yeah, okay, that's very, very interesting as well. The elements you've mentioned there, climate change, human, animal, that's part of the answer, I think, that exists. And I'll tie in this breakdown of silos as well, Alfonso's mentioned. There is an answer, I'm pretty sure that fits all of this. Claire, what's your view on this?
Yeah, I mean, I think what's often sometimes lost on scientists, sometimes like basic scientists, is the importance of communities, local communities, to vector control, and local education programs that are acceptable or that make sense to a particular community are really important. And obviously that's going to differ in various parts of the world. So I think actually public education in vector control and just studying what works and what works in different parts of the world, people are prepared to do or not to do in various parts of the world differs as well. So I think actually public education is often something that's underestimated in the fight against vector.
I mean, that's very interesting. If you look at the kind of word cloud, I was just writing down some of the stuff that you're coming out with there. Public education, you've said there, Claire, community engagement, silo breakdown. So, staying within a silo, no real attempt at multisectorialism, Alfonso. And then the climate change, human, animal, obviously the zoonotic concept there, One Health concept from Thomas as well in there. The SDG framework exists, right? The SDG framework exists, and we keep saying, we're very lucky enough to be in a consensus position from our meetings. You get a lot of different. The whole reason we constructed the ISNTD was to give that kind of feel to things, that we don't want just to talk about epidemiology or talk about molecular biology to molecular biologists. We want everyone to talk with each other. Yeah. So the SDG framework exists. Like the question to you is, should the healthcare SDG become, because of its inherent gravitas, should it become the endpoint measure for other interventions that sit underneath? So a climate change intervention that would sit under a different SDG could be measured for impact and effectiveness by using a healthcare indicator. Is that something does that make sense? Is there any resonance there? What are your views on otherwise the MDGs, the Millennium Development Goals, didn't really do the job. They've morphed into the Sustainable Development Goals. Are they now going to die? Or, there's all these different, what's your view on that? The healthcare indicators being the endpoint measure for different things.
I think if we're going to get sort of interconnectivity between different sectors, then there has to be sort of an acceptance of each other's indicators, if you like, each other's metrics. So I absolutely think so, Dr. Rafiq, that each of them. Yeah.
Mm-hmm. Thank you, Claire. Alfonso, you were about to say something, I think. Sorry. Yeah.
Yeah. As I agree with that, and certainly, as I was mentioning, when we discussed, for example, with the WHO about the approaches for the multisectoral participation in vector-borne diseases control, certainly the SDGs are fully discussed there. But again, the problem in this interaction in the need for an effective and sustained with eco-biosocial approaches for vector control needs the intervention of other areas that are certainly related to the development of these SDGs, and we need the participation of other sectors. Certainly, in healthcare sector, we need those measures also of other SDGs that are related to, for example, healthcare as well, specifically to vector-borne diseases.
That's a very interesting question, answer. Thank you. Thomas, what's your view on that? If you don't mind, you're probably the one who's done the most kind of digging around with different, totally Godzilla versus Tetsuko type of silos. So I want to hear what's your view on that.
Well, I'm not the expert basically on this field. From my part in working in Europe, we were dealing mainly with imported infections, and in Chile, like I said, we just discovered that we have something that we didn't know. Otherwise, Chile is when it comes to vector control and goals of vector control, was successful with Chagas, and we just discovered that we have something completely new. And if we look at the prevention and control measures regarding a mite-borne disease, we recognize that there is absolutely, basically, no knowledge. There's not even the knowledge how you protect yourself on an individual level. Yeah. So how to plan to protect and control the level on a population level. There's a lot to be done, and I think this is, like you said, it requires the interaction of ecologists, of public health people, of infectious diseases people, and entomologists. Basically, the whole team. And we also work, for example, with an anthropologist as well.
I was about to mention anthropologists, actually, to you just then. I was going to say, what about the anthropologists? In the mass drug administration world, it was the anthropologists who put out stuff that these drugs are not being used in a certain way because the program design is not. I'm thinking about Schisto as an example. Maybe this did happen when we first launched. Bring in the actual lived experience of the people, the communities, and design the programs from that perspective. And that is definitely the job for these anthropologists. So yeah, I was about to say that as well in there. I mean, yeah, there's food for thought. There's a lot of food for thought in that. Our meetings are basically designed for that. That's one of the progress through partnership is one of our actual mottos. Yeah, so we're delighted to have this as an end panel. There's never enough time to discuss things. I'd like to say that firstly. I'm being given the death stare again, and I will turn the computer around in a second and show you. The thing will cut off. That's why the way the system's configured. The questions that we've got from the audience, we have them, and we're going to put those into a format. And if everybody agrees, we'll send those to you over the next few days. And then once you've got time to answer them, we know you're very busy. Once you've got time, bring that back, and then we'll tease a white paper out of that around collaboration. The output is going to be white papers on each of the sessions. So if you're okay with that, if you've got time to do that, brilliant.
Sure.
So that would be great. I'd like to say thank you very, very much. Digital applause behind the digital veil. I'm sure all the audience is thinking, get him off the screen, because the pubs have opened in the UK, as you know, because it's the one thing that the COVID thing didn't stop. Yeah, was that. But I just want to say thank you very, very much for that. It's been today is the International Friends Day, I'm being told. Today is International Friends Day. We're actually advocating for a World Dengue Day to be ratified by the World Health Organization. And we had the backing of the 3 ministries of health earlier in the day. Today is International Friends Day. So on that basis, International Friendship Day. So on that basis, we'd rather reach out to yourselves and the audience, the wider audience, and say this site will remain live. It's not just a one-off conference site. It's live as a resource for everybody. You can post stuff in as you wish. It's an open login. There's no charge to use it. I would go for it. You've seen some of the spreads in terms of the countries that are the country spread in terms of the people, disciplines, silos that have been coming onto this. And so by all means, it's there for you all as a community, and we would be very interested to see how this progresses. It's our own experiment. So it's there. Yeah, that's the thing there. So that's, I think, the end of the actual. We've got a few seconds left, so I'm going to have to say thank you very, very much. Keep safe, everybody. Yeah, and yeah, enjoy yourselves, and wonderful. Thank you very, very much indeed. Thank you.
Take care all.
Goodbye.
Thank you.
Thank you.
Applause for you.
Yeah.